Hello guys, this is the Alias Theory Builder series where I explain theory, mechanics, and technical nuances of Alias. This is not a modeling tutorial, but a theory tutorial, if you will. Now today's topic is a Deviation 1 error, which is highly controversial, full of rumors and, well, let's say false claims. I will explain what it is, should you fix it, and if you should, then how. Now, you don't really need to follow me on this one, so I guess you can just, enjoy the show. But just in case, this is my construction options, so if you really want to try it with me along the way, well, you're welcome. Okay, so I will do one example where I will show you how to solve Deviation 1, basically bring Deviation 1, and then another one where I'll just explain what it actually is. So let me create a new layer like that. Am I capturing? I am, yes, okay. So let me open up this panel and I will use these CV curve options tool. New CV curve tool with a quartal node spacing with 3 degrees. Now I will do additional video in the theory builder about the node spacing. It's actually a pretty interesting topic on itself, but for now, just a rule of thumb: if you work with multi-span curves, which I'm not advising you to do, then quarter is the better option. Okay, now I'm making it deliberate here because I really want to show Deviation 1. So let me quickly build something. Let's go for maybe here. Maybe here, and then I don't know, will it be enough? Oh, probably. Let's make one here. How many have we? Have 2 spans. We need another one. All right, now we have 3 spans. Okay, that's enough. Okay, now let me build a profile like that. Should do the job. Now I will use the profile tool, change it to neutral, and the framing travel I will change to parallel, once again deliberately to show you different examples. Now the surface structure, I will click on Bezier. For now, I will change it later. Let me just hide it. Oops, sorry. And build it. Okay. Now this surface or this connection is a great recipe for Deviation 1. Let me actually illustrate. All right, so we have Deviation 1. Let me actually change it to the outer of the edges and the outer in the center, like that. Yeah, still a lot of Deviation 1s. Well, that's good. Now I will let it be for now. Just hide it and create the new layer, and in this one I will create 2 flat planes, so one on this one and another one. Let me just group that and snap it here and then ungroup like this. Okay, so as you can see, this is 2 flat planes. They do not have any curvature whatsoever, so they are plain. So what is the curvature? Well, curvature is a parameter that measures of how much a curve or a surface curves. So it measures technically by fitting a circle into the curve, and this is what I want to illustrate. Now, for now, one important thing is that if I will use the surface continuity tool and check it, you will see that the connection is curvature. But this is not actually true. So we all say, me and other people in the industry and in YouTube as well, like, okay, now we have curvature, but technically this tool doesn't tell you is it curvature or not. What it does is it tells you the deviation of a curvature, but it doesn't tell you does this surface has a curvature in the first place. Now, as you can see, this is a absolutely flat surfaces that doesn't have curvature, but we still have the green line and mark with the letter C, like it is curvature. But once again, it's a curvature deviation is within your tolerance set, which is, well, in the construction options, or 0. Okay, so what's happening with this surface continuity tool? Let's figure it out, because this is important to understand the deviation 1. So if I'll open it up, you will see that there is one really important parameter. This one, check spacing by. There's 2 options, arc length and per span. You do not need to bother about the arc length at all. The gold standard in the industry is per span. So what this does, basically, and what this tool does when you ask it to check the curvature deviation, what it does, well, after it understands that these 2 surfaces are close enough together even to perform the test, and by the way, in the construction options, there is a specific parameter called topology distance. So if this surface is at least somewhere closer or within this topology distance, it will perform the check. If it's further apart, it will not do anything. So it is within, and after that, what it does, it spreads the points. Now you probably can see, or maybe not, well, I hope you can see that there is a small crosses along the point of connection. So there is 10 of them total and 2 additional one on the edges, on the endpoints. The amount of these points are, once again, in your construction options under the curve fit checkpoints parameter. So mine set to 10. By default, I guess it's 5. But this is like the sweet spot. 10 is a sweet spot. But sometimes you have a situation when you align something to something with a very tight continuity option, so your curvature is 0.05 or even lower, and then you check your diagnostic shadings like zebra stripes, and you see a problem. Well, why was that? Well, that's because there is not enough checkpoints, or these points where the calculations of a curvature deviation happens to really catch it as a number. So it will be visible to you in the curvature comp. That's why there is additional parameter. Well, you always can change it here, just temporarily, or you select it using your surface continuity, holding or clicking on the middle mouse and slide it. You can see that there is more or less of them. Now this is a temporary. When I will deselect and select it again, it will go to the basic parameter. So just a small hint for you. Now, what will happen at this point? How Alias measures the curvature deviation? Well, it does it like that. So as I said, let me take this point. It creates a perpendicular line from the point. You can call it line as a line that perpendicular to the surface at a point, and then it fits the circle inside. So let me just really quickly kind of like illustrate it. So that's how it does. Let me shrink it. Okay, so it fits the circle. So the center of a circle is on this perpendicular line right there, and then it basically increases it from nothing, from 0, and just try to expand it and try to fit it to the edge of a surface or a curve. And when it does, it measures the radius of the circle and takes a reciprocal of it, which I'll talk a little bit later why it does that. But basically, it does it twice on one side and on the other side. Now, when I'm saying describing, so basically this circle should describe the surface or describe the curve fitting inside. And by fitting, it means it should connect at least twice on the point of connection here and somewhere else. Now, it's very kind of simplified example of it now, what the fitting is. But you can think of it as this. Now, the problem is, in this example, you kind of see that the surface is flat, which means that it doesn't matter. Let me just set the pivot here. Sorry, here. Come on. It doesn't matter how big or small the circle is, it can't describe the curve. It can't touch it again because this is a straight surface. What will happen as a result is that it basically can be infinitely large, but it will never mathematically can touch it anywhere else. So basically, the description of this flat surface from Alias standpoint is supposed to be infinity. And you're probably thinking, yeah, well, I wrote about that on official forums and Q&A sections. People say that's an infinity problem. Well, no, it is not, because Alias, like, well, any other tool, I believe, I use a reciprocal just to, well, it actually serves two purposes. First, eliminate infinity, and second, bring zero curvature as a value to the flat surfaces. So what do I mean by that? Let me just actually open up the markup lister and just draw it basically. Here's my pen. So a reciprocal is 1 divided by the number. Which number it is? It is infinity. So the reciprocal of infinity, if you remember the math classes, it will be 0 all the time. And this is exactly what we need, because infinitely large circle transforms to 0 using reciprocal, and as a result it perfectly describes the curvature of the flat surface. Curvature of the flat surface is 0, exactly what we need. Now, what happened next is when it calculates the radius of the point on one surface, it will do the same on the other one, and then it basically measures the two. So not just measures, but better say compares the two. And it compares it using a really simple formula. And this formula looks like that. Oh, once again, come on. Maybe here. Yeah, okay. So the formula works like that, looks like that. So radius 2. And once again, this radius, this one, is a reciprocal of a radius. It's this one. So reciprocal of radius 2 minus reciprocal radius of 1, and then we divide on the sum of them. So 1 plus 2. And then you will get some number. So number. So this number, you will never see if this number is 0 or within your curvature continuity tolerance. If it's lower, you will not see it. Or within, or if it is higher, you will see this number, and in the curvature comp, you do additional operations, realign, move CVs around to eliminate it, to bring it to this state where everything is within your tolerance set, and it says that the curvature deviation, once again, it's not curvature, it's curvature deviation, is within your tolerance set of 0. Now we going closer and closer to the deviation 1, so just don't post me. So one important thing here to note in this formula is we always divide on the bigger number. This one, it's a bigger number. So, which means that the result of this formula is always clamped to the values from 0 to 1. It can't be bigger than 1, but it can be 1. You're already right now trying to realize that, yeah, well, I never get the curvature deviation more than 1, 0.1, 0.05, 0.8, 0.999, 1, which is the deviation 1, but not more than that. Well, that's because of this. Now, let us try to calculate and figure out why we actually have this green, even though that the curvature deviation here is 0. Well, why was that? So click on this one again. So let's follow the formula. So what is the radius that describes the surface? Well, infinite radius for the reciprocal will be 0. Okay, that's cool. Let's put a 0 here. What's about this one? Well, it is the same. I believe you already see where it's going. So what will happen is in this formula, we will get 0. Not some number, we will get exactly 0. Both of them have 0 curvature, both of them, so no curvature, but from Alias standpoint, everything has curvature, just a curvature of 0. And the deviation of it is exactly 0. So as the deviation is exactly 0, it's within the tolerance, it's 0, it's green. That's why it's green. Okay, now let me replicate the deviation 1 error here. So I will take, let me just delete, I don't need that anymore. So I'll take the CV, this one, for example, the second row, and just push it up just a bit. Oh, no, not up. Okay, in no time, we have deviation 1. Now, let's go back to our drawing and to quickly replicate what we have here. Come on. So this one is still 0, so it will be 0. What's about this surface? Now we moved CV a little bit up. So now at this point it has some curvature. It's not 0 anymore, it's some number. Okay. Once again, it's really obvious what's happening here, right? So, and we divide on the sum of them. So, well, obviously zeros cancel each other out, and you divide this number on itself. So it doesn't matter how big this number, how far you push the CV away, or how tiny the deviation is. It literally doesn't matter because we divide it on itself, and as a result we always get 1, deviation 1. This deviation 1 is the result of this formula. Now, the problem with the deviation 1, now as you know what it is, the real problem with it is you don't know the actual deviation. Because of the formula, you divide the number in itself, so it is very tiny, but, you know, watch, I will just take this stuff, right, and just push it up. No, so what I'm doing, like this, right? But it didn't change the curvature comp, it's still deviation 1. It didn't really become bigger or smaller, it's just still deviation 1, right? So, and I can just do dumb shit, you know, I can just put it somewhere else. Well, let me just actually realign that to the edge, because I kind of butchered it a little bit. Why am I doing this? Okay, and check it. And you can see that, well, it's definitely an error. It shouldn't be like that. But once again, you see a deviation 1. And this is the problem. As the actual deviation can be huge, obviously like visible by a naked eye, or it can be very tiny, but as you divide the number in itself, it always will be 1. So you're kind of like oblivious, you don't know. And as a result, it's kind of tricky to solve manually. On top of it, it's even difficult to understand, is it really just by the curvature comp? Is it really a problem or is it not? And by the way, the answer on the question, is deviation 1 an error or it is a warning message, like some Q&A managers tells you, well, yes, it is an error. It is an error. Yes, this is the deviations. It's actually maximum deviation which you can get as a result of the formula. Okay, so let me actually realign it back. So some people say, okay, that's all cool and all, but isn't that means that the deviation 1 can happen when one surface is flat? And the answer is yes. Yes, it is. Now you can say and can argue, well, it's not true. I have a lot of curved surfaces and I have deviation 1 here. Well, the one important note here is that we perform, or the tool performs, curvature deviation check at a point, only at a point. So if I will, let me just replicate the deviation 1 really quickly, like this. So for example, I can push that down and it's definitely a curvature, isn't it? Like, look at this, it's definitely curved and you still have deviation 1. Well, you can take this one and push that up. So what? Still deviation 1. Well, why was that? It's curved surfaces. Yes, they are curved, that's true. But from the standpoint of this point, like this point which Alias spreads, it is flat because it works within 2 CVs which are collinear. And let me actually do another thing and use a curvature comp here. Now, as you can see, there is a point here where the positive acceleration transforms to the negative acceleration. This point called inflection points, and we have a specific tool even to break the curves at inflection points. But what's more importantly is at this point where inflections comes. Now, you don't really see it here because you can see there is a deviation because I moved CV, but in this one it should be perfectly spot on. And it does. Specifically, at this point, there is no acceleration. And it's just on the point, not a little bit further away. And that's why it's so important in theory when you align one surface to another surface, and the one surface is basically have zero curvature at a point, you need to align it collinearly. So basically you need to be symmetrical here. Not specifically symmetrical, but the CVs should be collinear. This is actually the right way to eliminate deviation 1, but of course it's not that simple. Anyway, so I guess it's now pretty clear what the deviation 1 is, and where it came from. Now it's the question of, should you solve it? And if yes, then how? Now let me hide this layer, and I will open up this one. So a main thing to note, let me just hide this stuff. Hide this. I just actually delete this. Come on. Yes. So first of all, to answer this question, there is no kind of like one universal question like should you fix it or not. In general, the situation where I took the CV and move it somewhere extremely further away and have the deviation 1 in return, in practice is, well, unrealistic, because in most cases you rely on Alias, and Alias does the work, like with this example of the fillet command. Now it still didn't do the perfect job, and we have the curvature deviations with the number, the actual curvature deviation, and the deviation 1. But if you have this deviation, 99%, it's extremely minuscule. Basically, solving it's like playing math games with Alias. And you can do it, and you can eliminate all the deviation 1s, but it's not really that necessary. The only important thing to note is that before you consider let it go and move on the other parts of the model, is to use your diagnostic shading to check that it really doesn't have a problem. So for example here, let me just actually automatically trim it like this, and if I will open up my diagnostic shading and change it to the vertical, there is no problems. It looks all right. Now, you don't really need to change it technically, fix it technically, but sometimes you create surfaces manually, you move CVs manually, and you get a deviation 1 in return. Well, obviously you need to check it first, but that's where the problems can come in, and you need to solve it. Anyway, different situations may happen, and sometimes you may be crazy, or you have all the time in the universe, and all of this kind of like stuff is bugging you, and you want to change it or fix it, or this is the real issue, you want to fix it. How you can do it? Well, as I said, you can, and it really depends on your surfaces. There is no one universal method, but there is a few methods which combined together or separately may work really well. And once again, as I mentioned, it really depends on the surface structure. So to illustrate it, I will create, basically I make three examples. So this one is the first one. Let me go back to my standard shading. So how we solve this one? Now remember, when I created this example, these surfaces are separate. I deliberately clicked on the Bezier surfaces, which is actually a very vague description of what it actually does. But basically it's all the surfaces here are NURBS. So technically just a dumb term, but it splits the surface instead of a spans, it separates them on the separate surfaces, that's it. But this is very beneficial for the fillet tool, because Fillet tool now knows where the edges are. It will be really easy for them to align, for the tool to properly align the structure of a fillet. So I will consider this as a simple example. Now, to make it a little bit more complex, I will set the edges to auto, which means automatically as edge align. And these profile here is parallel, once again, for the same reason. It's for demonstration purposes. Now, as you can see, the surface is bent a little bit because this is edge aligned and this is edge aligned, and as a result, it transforms to the whole surface structure. But as these surfaces are separate and we know where the edges are, it's not that big of a deal. So how we solve this? Well, one of the examples, I said there is a few different methods. One of them, obviously, is to use align tool. Now, when we built the fillets, we didn't use align tool, we used a fillet tool. And didn't do a best job in the world, but it does the job, it's not perfect. Well, use align tool and realign it. It's totally standard pipeline. When you create a fillet, doesn't work, there's problems, you use align tool. So this is the same. You have a problem. In this case, this is a problem we don't really need to solve, but we can, and we will solve it by using align tool. Now, the good rule of thumb is not to align to the edge when you have a trimmed edge, one of the golden rules. Now, you can, sometimes it works, but in most cases it doesn't. So let me quickly solve this. And first I will delete the history, retrim this and this, delete the cursor surface, and use project tool with position influence set to 0. Now I will talk about the position influence for the fillet tool here as well. I don't think it just really need a separate video, but it's kind of important parameter. So just project using normal direction, and here we go, it's curvature. Let's repeat the step, and it's curvature. So one of the methods, use align tool. Now let's go here, same thing. Let's retrim. Is it curvature? No, it's not this one, no. So let's retrim all of them and reproject. So here, here, and here. Oops. Curvature, 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 curvature. This one is not a curvature, so delete and project. As you can see, doesn't take a lot of time, really simple and fast, and everything is curvature here. Now let's work with this one and quickly finish it. So yeah, this is, looks like it's, yeah, only these two. Okay, so retrim, delete these curves and reproject. Now, another way, so sometimes you just reproject and still have the deviation 1 error. What are you going to do here in this situation? Where, so there is a couple ways. One of them is just wiggle CVs a little bit, trying to eliminate this discrepancy by using position influence slider. That's where it just probably makes sense. So as you can see, bam, and we eliminate the problem. And now I need to explain what is the position influence is. So if you don't know, it's basically, as you can see, it's a slider from 0 to 1, where at 0, you as a user of Alias are in full control over the CV structure of the surface, which you have. And at the positions of 1, Alias takes the full control. So what does it mean full control? What you can imagine it as, imagine that you have, I don't know, a rock on a rope, and you hold the rope, right, above the ground. So if you lose the grip, the rock will fall, and it fall on the surface and lay down on the surface based on the surface on the rock and the force of the gravity. Now, that's the same as the position influence set to 1. What Alias will do, it will discard the surface structure of your surface before alignment and move the CVs around the way it designed to. So basically it will strive for collinearity. So it will shift CVs and try to collinearly align that to the surface. When the position influence is set to 0, it means that, once again, with the reference to the rock, it means that you're still holding the rock and you can push it up or down, left and right. You're in control of the rock, but the gravity will still be pushing on it, right? So this is the same. When the position influence is set to 0, Alias will still align, try to align because you ask it to align, but it will move CVs minimally. It still will shift it a bit, but extremely tiny. It still will try to preserve the surface structure you have, well, basically as much as it can. Both of the methods are extremely useful in the different situations, and sometimes, as you can see, one is more beneficial than another. So in this case, if I will move CVs to the right, I immediately eliminate the deviation one by collinearly align it to the surface. But that's not the only option. I can just remove it, and instead of doing this, I can bring more data for Alias to work. So it is 5 degrees. I can ask it to preserve the same structure, but bring more degrees and more degrees and more degrees, and eventually it will work. Now, in general, these surfaces are cleaner, but they need more structure to work, right? Because it's not ideal. In this current situation, it looks accurate, it's all good, but you just need more definition for that. And when you go back and use position influence, it slides them a little bit to accommodate the surface structure of the surface you align to. So as you can see, it works as well. So these two methods is always used or applied as well to solve the deviation one. And position influence definitely not only for that. Now, let me reproject here, check the continuity. All these ones perfectly fine with the position influence set to 0. I don't need to do anything. What's about these ones? Yeah, let me project them. This one and this one. Check, check. So these ones is all good. Now let me trim. Okay. So as you can see, it wasn't really hard, and if I didn't really chat that much, I'll probably do it in a few seconds, just quickly reprojecting everything, and it works. But this is a simple example. The examples might be a little bit more complex in terms of the surface structure. For example, let me now delete this fillet at all and retrim this. Let me delete all the curves and surfaces, and I will show you another example. So I will use a query edit on this profile, and instead of the Bezier, I will just uncheck it and update. Right. What will happen now is this is a single surface with free spans in it. Well, and that's much more painful. Now, there is a lot of situations when you really need to build a surface, and yeah, sometimes happens they really have spans of 1 or 2. It's fine, it doesn't really consider it as an alternate class, at least for the different types of industries. There can be different standards, but it happens. Even in automotive industry, it happens. It's okay. But they obviously have a caveat. One of them is that there is no true edges anymore. This is a one separate surface. Well, first of all, it's continuity kind of shit. You can see that this spikes. Well, that's the nature of the multi-span surfaces. Nothing we can do about it. But what's worser is that we don't have a true edges anymore here. And the surface fillet doesn't really treat them, doesn't understand them. So it works across the spans. It's a blessing because it's good that it can do it, but it's the curse that you can't really specify that you don't really want that. So in result, let me just create the fillet again. And as you can see, now we have more problems here. Now, as you can see that some of the surfaces goes across these endpoints and basically the span. That's not ideal, but this is not the end of the world. Although, I would like to mention that in these situations, let me just trim it. So in situations like that, these skewing from the edge lines are not ideal. They actually makes our life much, much, much harder. So in these situations, when you have a span surface, instead of using auto or edge line, you use default. And by the way, this interior auto doesn't mean anything because once again, fillet tool doesn't understand spans. Okay, Oh, it understands spans, but it doesn't really treat them as an edges. Okay, so now when we have it, the surface structure is much more accurate. It's perpendicular. But as you can see now, this fillet doesn't really comes all the way to the end, and it's not edge aligned. Once again, in the situation with the multi-span surfaces, it's better to do it like this and quickly fix it. It's not a big deal, but we will save a lot of time, and you will understand later why, because I show you the next example when I actually don't do that. Right, so first of all, what I will do here, I will delete the history, and I will extend the CV a little bit, part of the surface, and then just go here, create the line, and project on the Z direction, like this, and trim convert it, like that. Okay, that's cool. We will realign it later. So this one's supposed to be already aligned because it's a perpendicular edge. Okay, now let's work with these parts now. As they are all perpendicular, it will save us a lot of time. So all of this is, not all of that, actually, this one is okay. So basically the next steps will be the same. We quickly reproject. Oh, this one is pretty good, good, and this one is not good. Okay, so let's do these two. Quickly reproject using project and the normals. I will use edge here on this side, like that. Now let me delete this one, quickly reproject. Now we have a deviation 1. Once again, I can try to use position influence here, but as you can see, in this case, it doesn't really work. So I'll put that back to 0. I don't want to mess up with the structure and just bring more degrees. Here we go. It's solved. Now this one is okay. These one have actually number, so that's the real problem. Okay, that's good. Let's reproject. And what's about this one's fine. This one is fine. Now it's fine. If I really left it skewed, there will be a big problem. But you know, we avoided that, so that's good. Let me delete this one. That's the real problem. Okay, and that's the real problem too. No, it's a fake problem, but it is technically an issue. Right, so this one we have a deviation 1. Let's reproject. Now, as you can see, we have a deviation here. Now, the more CVs I bring here, it actually doesn't really want to go away. Well, that's something that happens quite a lot. So I can try to align it as an edges and try to increase, but even still, we still have some problems. Now, you may try to go to the 5 degrees like this, and now we don't have a deviation 1 at least, which means that we can solve that manually. And this is the third method when you align these CVs manually, or you will try to use collinearity with a higher degree, but I'm sorry, not this one, this one. But it rarely helps, and it doesn't in this case as well. So what we're going to do, so push this back, and we will try to solve this using the manual CV adjustments. I'll delete the history and see. Now, I never know will it work or not. I'm never sure. You never can be sure with the deviation 1 error, but in this case it works perfectly, just a little touch, and it works on place. Let's work on this one. Now let's project again. And here, still preserving curvature, all good. Spot this one, it's all curvature. So now we finished this one, which is a good thing. Okay, now let me trim this. Oops, sorry. Let me delete the history and then trim this. Yeah, whatever. Okay, so this is the second example. It's a little bit more, now it's not more complex than the previous one because we actually use the default alignment. Now let me do it third time. This time I will delete these fillets, retrim that back. Like this, delete. And this time I will use the fillets with auto or edge align. Technically, it doesn't really matter in this situation. So, okay, so now we have this structure, and once again, let me automatically trim it. So this is almost the same example. Once again, it's a single surfaces, and now we need to try to fix this. So let's just try to do that. Now, this one is good. Well, not quite, actually. All right, so what I will do as usual, I will delete the history, retrim everything, and I'm not sure that... So this one actually works fine. That's a great news. Now these one. So I need to delete these, and these, and then reproject. Now, so far I'll kind of do the same thing. Anyway, I'll just kind of delete everything. It will be faster. So curvature. Now, let's work on this one. Okay. So, as you can see, because of the edge align, we skewed things pretty significantly here. And now, it just doesn't want to work. So, let me revert that. Now, what we can do in this situation? So we basically tried the position influence to 1. We tried to increase the degrees, right? We can go to the edge align, so basically try to be collinear, but yeah, no luck. So what else can we do in this situation where there is not enough data? Now, you know, you have like a 9 degrees, it's not enough. Another way to do it, and once again, it's not always work as well, but what you can do is you can separate the surface and bring more details. So let me do this. So I will go to, I will take this surface, let me just, oh, come on. So I will just ungroup this. I will take the surface, duplicate that, duplicate that, template that, and this surface I will detach. Now that kind of helps. It's a lot when you work with a decent structure. Now already, if I will, let me just kind of hide this and project. Sorry. Now this surface is still, no, not this one, this one. So let's move the CV, bam. Okay, so now by splitting the surface on 2, I was able to, well, achieve the goals, and now this one is curvature. All right, now this surface is not ideal, so technically we solve the problem, yes, by separating the surface on 2, and as a result solving the problem. But this is not ideal solution, because the more small surfaces you have here, the more dimples it will be. Now, in this example, it doesn't really matter, because it's pretty simple. But in terms of the structure, it's definitely not a class, not even close. Like any of those with the span surface is not. So we need, in general, in the proper way of thinking, we need to solve it actually in a different manner. So let me show you the last way how you can solve the deviation 1. So basically what we used project align with position influence 0 and bringing more degrees, with position with the same degrees or bigger degrees, but the position influence somewhere closer to 1, where Alias tries to collinearly align it and eliminating there this way. Then we use the detaching surfaces by just not just bringing more degrees for Alias to work with, but literally separating the surfaces and bringing twice as more degrees basically to operate, which solves the problem as well. But even still, this one is not always enough. Now, I believe I can do like a different example and bend it like really drastically, and that will not be enough. And in these situations, you need to do a different method. So I will just demonstrate it here without really rebuilding anything. So this surface is kind of bad. It's skewed on this side. It just separates. It separates the span. Not ideal. So what you can do is you can create the perpendicular line. And by the way, you can create perpendicular lines using perpendicular tool from the from the orthographic view. Sorry, let me just kind of extend it right there. It is perpendicular, and then I will use rail tool, or I can use the profile tool, doesn't really matter. Let's extend like that, like that. And instead of separating it on isopams, right? So basically, we separated this surface just on half, if you will. We can separate it more accurately using the span itself. Now, as you can see, the surface is just following the span, which is very beneficial and solves a lot of problems as well. So I insert current surface, and then I want to trim convert. So which surface I will trim convert? Now this one is the shorter edge, so I'll probably convert this one, and this one I'll just delete. Don't need that really. So it's still not curvature anymore because that was a different curve and surface. So what I need to do is I quickly retrim, delete this, and then reproject. And here as well. So just in 5x5, no problems whatsoever. Now we need to create another surface, but it's really cramped. So what I do is I'll just give it a little bit more room to breathe. It will definitely eliminate all the potential issues with dimples and irregularity of the surface. So let me reproject. I am just reprojecting, not realigning, because I already know that it is aligned properly. Now let me select this and this surfaces and create the transition here, like that. And now let's bring curvature here and here. Let's bring collinearity. It's all curvature, that's good. Let's delete this curves, we don't need that anymore. And then project. And here we go. Now we can trim and trim. Now as you can see, this example where we have a trim on the span is really close to the first example where the surfaces were separate. This is very beneficial because on this example it's a little bit simpler, but on the complex examples when you have a lot of filleting around complex objects, this stuff almost always eliminate deviation ones, and not only deviation ones, the actual deviations. So, well, as you can see, there is a few methods to eliminate deviation ones. And by the way, let me quickly just check the zebra stripes. Once again, the actual look of it doesn't really change. So if I'll ask yourself, if you ask me again, so should I really solve a deviation 1 error? Well, the answer will be check it with your zebra stripes first. If there is no problems, you shouldn't do it. If there is a problems, you definitely should do it. And there is a few options for you to work with. So increasing amount of degrees to bringing more data for Alias to work with, using position influence to try to align collinearly, even if you're projecting. In the older versions of Alias, there is no such an option as collinearly aligning when you project. But in the newer versions, Alias, newer, Science 2013 or 14, I don't really remember, there is an option to do so. So it's really beneficial in these situations. And separating the surfaces based on the surface structure, or even just splitting that apart. All of these methods as a separate or combined can solve deviation 1 errors absolutely everywhere. So there is 100% chance that it doesn't matter how complex your model is, you can build it with a single deviation 1 when you align to the flat surfaces. And once again, as a final note, you will get deviation 1 when the point on the surface you're aligning to basically have zero acceleration. So one of the portion of equation is missing, or not technically missing, it's zero. So that's where you get it. All right, guys, I guess that's pretty much all what you need to know about the deviation 1. So thank you very much for watching, and I'll see you in the next one.